3I Atlas is moving more than 3 times faster than our best efforts after nearly 50 years of flight. We saw it pass perihelion in October 2025. We tracked it past Earth's orbit in December, and now we watch it approach Jupiter. The frustration in the astronomical community is palpable because we know what happens next. After March 16th, gravity will do its work, bending the trajectory slightly, but the kinetic energy of this traveler is too high to be captured. It will not stay. It will punch through the gravitational web of the giant planets and fade into the interstellar medium. But why does this specific velocity matter so much? Why is 58 kilometers per second the number that breaks our current capabilities? It comes down to the tyranny of the rocket equation. To catch 3I Atlas, a spacecraft would not only need to match that exit speed, it would need to exceed it to catch up. And it would need to do so quickly enough that the target hasn't already traveled light years away. A standard launch from Earth, even with a Jupiter gravity assist, would leave a probe drifting hopelessly behind, watching the comet shrink into a star-like point of light that never gets any closer. This feels like a defeat. It feels like the universe has thrown a diamond through our window, and we are too slow to catch it before it hits the floor. We will see the surface of a visitor. We will know its chemical composition. We will see craters formed by collisions in another star system. We will see the weathering of interstellar dust. But there is a final layer to this story, a layer that goes beyond the science and touches on the existential. If we launch this mission, we are sending a message, not to aliens, but to ourselves. We are telling our future selves that we believed in the value of knowledge enough to plant a tree we would never sit under. And as we approach the final chapter of this investigation, we have to consider the ultimate payoff. When those images finally download, sometime in the late 2080s, what will they show? Will we see a jagged lump of ice, a metallic shard? Or will we see something that forces us to rewrite the history of life in the galaxy? The wager is on the table. The launch window is approaching. The question is, do we have the nerve to take the bet? This returns us to the fundamental question of the wager. The mission to intercept 3I Atlas is not a guarantee. It is a probability game played with rockets and gravity. We are betting technology we haven't fully mastered against a target we barely understand, across a time span that usually crumbles human resolve. But consider the alternative. The alternative is to stand on the shore of our little gravitational island and watch the ships sail past, one by one, without ever trying to board them. The alternative is to accept that 58 kilometers per second is a speed limit on our curiosity. It is to accept that we are stuck here, passive observers of a universe that is teeming with motion. The proposal by the Initiative for Interstellar Studies is a rejection of that passivity. It is an assertion that physics is not a cage, but a ladder. If we can endure the heat of 3.2 solar radii, if we can endure the silence of a 50-year cruise, we can catch the uncatchable. Let's fast forward to the end game. The year is 2085. The interceptor, battered by decades of cosmic rays, wakes up. Its sensors lock onto a faint point of light against the background stars. The relative velocity is closing. The software, written by coders who are now grandparents, executes the terminal guidance sequence. The first photons from the close encounter hit the sensor. The data is buffered, encoded, and beamed back toward the distant spark of the sun. On Earth, a new generation of scientists waits. They are looking at screens in a control room that probably looks nothing like the ones we have today. But the anticipation is the same. The signal arrives. The image builds, line by line. Scenario A. It is a rock, a jagged, strange, dark asteroid from another star. We see tholins, organic compounds turned red by radiation. We see craters. We confirm that the building blocks of planets are the same out there as they are here. This is a scientific triumph. It validates our models of planetary formation. It tells us we are not special in our composition, only in our location. Scenario B, it is something else. The surface is too smooth. The composition is isotopic alloys that don't occur naturally. The shape is geometric. The whispers of non-gravitational acceleration were not outgassing, but something engineered. Even in Scenario A, the boring outcome, we win. We prove that we can navigate the solar system at will. We prove that we can manipulate energy on a scale that turns the sun into a propulsive engine. We confirm that humanity is an interstellar-capable species, at least in terms of reach. But in Scenario B, if that image shows anything artificial, even a dead, derelict shard of technology, then everything changes. The history of the human species divides into before intercept and after intercept. Our place in the universe is instantly redefined. The silence of the cosmos is broken not by a radio signal, but by a physical artifact, and we would have missed it if we hadn't taken the shot. If we had looked at the 58 kilometers per second speed and said, "It's too fast," if we had looked at the solar dive and said, "It's too hot." This is the essence of the deep dive. We analyze the impossible to find the improbable path to the necessary. 3I Atlas is leaving. It will cross the orbit of Jupiter in March 2026, and then it will climb out of the gravity well, slowing down as it goes, but never stopping. It is heading for the stars. The Comet Interceptor mission, the one we have on the books, is a fantastic piece of science, but it is a waiting game. The Solar Oberth Mission is a hunting game. It captures the spirit of our species, the part of us that looks at a receding horizon and decides to run. We have the technology. We have the math. We have the target. The only variable remaining is the will. As this object fades from our telescopes in the coming months, remember that its story isn't necessarily over. It might just be the prologue to the longest chase in human history.